Hey MMS, so today we're going to be learning our first lesson in Chapter 10, Volume of Rectangular Prisms. Okay, so we have the title up here, Chapter 10, Lesson 1, Volume of Rectangular Prisms. In Chapter 10, we're going to be learning about volume and surface area. And in today's lesson, it's just about volume of rectangular prisms. So we've kind of discussed a little bit in class what a rectangular prism is. We talked about it in our inquiry lab, but I would like us to write a formal definition. So I have written over here prism, and we're going to write down what a prism is. And this will be applied to every type of prism because there's a lot of different types. But just in this lesson, we'll be focusing on rectangular prisms, which we'll also talk about. So if you have grid paper, that would probably work best for this chapter. If you don't have grid paper, either do your best to try to trace these figures that we're going to draw, or go ahead and grab some grid paper. I have some extras in my cabinet drawers. Okay, so we are going to make a prism, so we have a visual. If you have grid paper, go ahead and draw one diagonal line. Okay, it's going to look something like that. So one diagonal line from one corner of grid paper of your grid square to another corner. Okay. Now this is going to be about 3 squares across. And then this is also going to be 3 squares across. And you can go ahead and connect that last diagonal there. Because I don't have grid paper, my drawing may not be as good as yours, but hopefully you can get the idea of what we're trying to do. Okay, so we have one diagonal here, 3 square grids across, and then we're gonna go 2 squares down. Two squares down. And we're going to do that for this one over here as well. Okay, and then I'm just going to connect these lines. Okay, so I have my rectangular prism here. Now, a rectangular prism is a 3D image, right? And if we pretended like we could see through this box, okay, it's sort of like a box. I'm going to draw some dotted lines, and those are going to help me to kind of see that it is 3D and that I can see through it. So I'm going to make dotted line there. Okay, kind of the same as this solid line, but it's a dotted line saying that I'm seeing through it. And I'm going to make a dotted line going down from that corner, just like this one here. Now I'm going to make a dotted line from here to here, just like that. So I can kind of see that I am seeing through this rectangular prism. Okay. So now that we have a good image, let's define what a prism is. So a prism is a 3D figure with parallel and identical bases. So my bases would be this right here and then this surface on the top. Okay, so it's parallel. They're never going to connect, never going to touch, and they are identical. Okay, so let's write that down. It is a 3D figure with parallel and identical bases. All right. Now that we have a good idea of what a prism is, let's move on to talking about volume. Oh, yes, but before, so just so we have some good visuals, okay, this is what a prism is. It's a rectangular prism. It is 3D, and I've put some paper, some yellow paper, on its bases. So this is a base, and this is a base, okay? And we can see that the bases are identical and they are parallel to each other, okay? And if I expanded this, they would never touch, okay? So these are parallel and they are also identical. Now I could also say the other sides are also parallel and identical. So I could say this is a base and this is a base. They're parallel and identical. I could also say this is a base and this is a base, parallel and identical. So that might look something like this, right? I have my original bases that I said with the yellow paper, but I could also say this side and this side are bases because they are parallel and identical, as well as this blue side. So the point being that the bases are parallel and identical, and as long as you have two sides that are parallel and identical, they are a base. And that a prism is a 3D figure. Okay, we also have something that looks like this. Now this is a triangular prism. Okay, we have a triangle on this side, and then we also have a triangle on this side. And we have this as a base, and this is also a base. They are parallel, okay, they're not going to touch, and they are also identical. One more example, hexagon on this side and a hexagon on this side. This is also a prism, okay, and we have our base here and a base here. They are identical and they are parallel to each other. This is called a hexagonal prism. Now back to this, we talked about volume in our inquiry lab, and we said volume was the amount of space that a figure has, right? So if I'm talking about the amount of space in this rectangular prism, I'm talking about volume. So if I were to put some water into this, or sand, I would see how much water could fill up this entire thing, right? Or how much sand would I use to fill up this figure, okay? So let's write a definition, and we kind of talked about this definition in the inquiry lab. So volume is the amount of space inside a 3D figure measured in cubic units. We also talked about how volume is measured as cubic units, okay, which looks like this, units cubed, right? Units to the power of 3. And you can say this as cubed. So just like with area, we say units squared, or unit to the power of 2. We say units cubed for volume, and it's pronounced cubed. I'm going to highlight a few things here. So with volume, it's important to note that cubic units is what we use. This is how it may look, and this is how you say it. Okay, with prism, it is important to understand that a prism has parallel and identical bases. Okay. So we are going to talk about what the volume formula is, and then we're going to show 2 examples, and we'll be done with our notes. So let's start with the formula. So the volume formula, it'll be different for every prism. So for example, this prism has a different formula from this prism, and just the same, this prism has a different formula from this triangular prism, right? So we are going to just focus on rectangular prism formulas for today. So I'm going to put rectangular prisms. That's the formula we're going to be using. I'm also going to let you guys know that before you start every problem, you need to list what the volume formula is for that prism, okay? Or whatever volume you're trying to find, you need to have your formula, just like we were doing for area. So here's the formula to find a rectangular prism, the volume of a rectangular prism. Volume, V stands for volume, equals the length times the width times the height of a figure, okay? So for example, up here we see length times the width times the height, okay? And then this is probably the most common formula you're going to see, but you also may see this formula. Volume equals capital B times the height. I prefer this formula over this formula, and you're going to see me using this a lot. This, however, volume equals capital B times the height. The B stands for the area of the base. Okay, so let's write that down. Area of base, which is found by length times width. So you're pretty much doing the same thing, right? You're still doing length times width, but they just call it capital B. So just know we are probably going to be using this. Okay, now that we know the formula, have the formula, let's start solving some problems. So the first problem we're going to have to find the volume for. Okay, so you're going to be given what the length, width, and height are. So in this problem, we know that the length is 6, the width is 3 1/4, and the height is 12 1/2. Okay, so we're going to start with the formula. So I'm going to write the formula. Volume equals length times width times height. I'm going to write formula over here. You're going to hear me saying this in class a lot. I'm going to say formula, work, units. Because to solve these problems, we're going to do those three things. Okay, formula, work, units. We have the formula. Now we're going to start with our work. So I'm going to plug in these values into my formula. So volume equals, I know that the length equals 6, so I'm going to replace length with 6. I know the width equals 3 1/4. But since I have a mixed number here, I need to convert this fraction into a decimal. Okay, to do that, I'm going to divide numerator by denominator. You can do that in your calculator, so 1 divided by 4, you're going to get 0.25. So my decimal for this mixed number is 3.25. So 6 times 3.25. And I'm going to do the same thing for this height. I'm going to convert this fraction into a decimal. So 1 divided by 2 is 0.5. So my height is 12.5. Okay, this is the work. Now I'm going to just put this into my calculator. I'm going to do 6 times 3.25 times 12.5. If you do that in your calculator, you're going to get 243.75, and you need to add your units. So because this is volume, I know that's units cubed. Okay? So here's my answer. On a test, this is what I would expect to see. I expect you to write the formula, show your work, replace these variables, length, width, and height, with the numbers associated with them, and then calculate this on your calculator. You should get your answer and include your units, and it should be units cubed. We have one more example, and in this example, there is actually going to be a missing dimension, and we're going to need to find that missing dimension, but we do know the area. So find the missing dimension. Okay, so here we're given volume. Volume equals 37.5 inches cubed. We're given the length. The length is 2.5 inches. We don't know the width, and we are given the height. The height is 3 3/4 inches. Okay, so I'm going to start with my formula. My formula is volume equals length times width times height. Now I'm going to plug in these values into my formula. So I know what the volume is. It's 37.5. I'm going to, and that equals length times width times height. My length is 2.5 times my width. I don't know what my width is, so I'm just going to put a W, times whatever my height is. My height is 3 3/4. Okay, so this is my work. Now I'm going to rearrange this. Okay, what I want is to multiply 2.5 times 3 3/4. And I can do this, right? I can ignore the W. I can multiply 2.5 times 3 3/4. That's part of the commutative property, saying that order doesn't really matter, okay? We're still going to get the same answer. So 2.5 times 3 3/4, put that into your calculator. Once again, we're going to rewrite this into our calculator. We're going to turn this into a decimal. So 3 3/4, well, 3 divided by 4 in our calculator is 0.75. So I'm going to multiply 2.5 times 3.75. And you are going to get 9.375 in your calculator, and we are still multiplying the W, the width. We still have 37.5 here. Now you're doing 3 things right now. 1, identify the variable right here. Step 2, what's happening to your variable? Well, it's being multiplied by 9.375. Step 3, undo what's happening to your variable, okay, by using inverse operations. Inverse of multiplication is division. So I'm going to divide by 3.75 on both sides. 9.375 divided by 9.375 is just 1, and 1 times W is just W. And then if you put this into your calculator, you're going to get 4. Okay, and I need my units. The units are inches. Okay, because width is in inches. So that's how you solve those type of problems. Remember, we need to see formula, work, and units. Let me know if you have any questions. Thanks.